Okay, so for our first question, we're going to be converting from radians into degrees. So should be a very quick question, very easy. So it's really 4 times 180 divided by 3. We replace pi with 180 because if you remember when we did this lesson, pi radians is the same thing as 180 degrees. So here, when you actually multiply this through and you clean it up in your calculator, so you should get 240 degrees, and that is in the third quadrant. For the second one, this is 11 times 180 divided by 12. So you type that right into your calculator, and you should get 165 degrees, which is in the second quadrant. So evaluating is the same thing as normal evaluating. However, here, we're going to be evaluating with radians. So we're going to be plugging in each of these radians, and we're going to look to get exact value. So for the first one, we're evaluating 3 pi over 2 into this whole sine function. So this is 3 times the sine of 2 times 3 pi over 2 plus pi minus 4. This is a pi. All right, so this is 3 times the sine. These cancel, so this is 3 pi plus pi minus 4. So 3 times the sine of 4 pi minus 4. So you're going to type into your calculator just sine of 4 pi. That way you can get that exact value. It ends up being 0. So 3 times 0 minus 4. 3 times 0 is 0. Minus 4 gives me negative 4. For number 4, we're going to plug in pi over 6. So this is going to be 5 minus 8 times the tangent of 4 times pi over 6. So this is 5 minus 8 times the tangent. This cleans up to end up becoming 2 pi over 3, which is a special angle because pi over 3, again, is 60 degrees. So when you type this in, you can type the tangent of 2 pi over 3 right into your calculator, and you end up getting that negative 1.732 number. Though that's one of your special decimals, so you should know that that is negative square root of 3. So when you actually clean this up, you get 5 plus 8 times the square root of 3. There's nothing else I can do. And this is going to be exact value. Okay, I actually don't say that in your directions. On your exam, it probably would come up as exact value, so you would have to actually go through and make sure that you're not writing decimals. You are writing the exact value for these. For number 5, 3 pi over 4. So this is g of x, so we are plugging in 3 pi over 4. So this is 3 pi over 4 plus pi, then minus 4. So this is negative secant. You can type this into your calculator. Type in the pi after, like just plug that in. So in your calculator, you should really do 3 over 4 plus 1. You end up getting 7 over 4, and then you, of course, still have your pi minus 4. The reason why you can't plug pi in with it is because pi is irrational, so it's not going to give you back that nice fraction of 7 pi over 4. So then I type into my calculator the secant of the cosine of 7 pi over 4, because secant is the reciprocal to cosine. So if you want to put this maybe somewhere on the bottom, I'll do this. So you do the cosine of 7 pi over 4, and you end up getting the square root of 2 over 2. However, up here, when you go to plug this in, you have to do the reciprocal. So this is negative 2 over the square root of 2 minus 4. Okay, and then you want to make sure that you rationalize this. So this is negative 2 square root of 2 over 2 minus 4, which your final answer, because these cancel, is negative square root of 2 minus 4. For number 6, last one here, we are evaluating pi over 2, so that's going to be 90 degrees. So we have 3 plus the cosecant of 4 times pi over 2, all divided by 3. So this is 3 plus the cosecant the top part here, 4 and 2, ends up becoming 2 pi, and then you're still dividing by 3. So same thing here, I'm going to have to do a little bit of side work on the bottom because I can't type into my calculator this reciprocal function. So I need to do the sine of 2 pi over 3, get exact value. You should get the square root of 3 over 2. But up here, you're going to do the reciprocal. So this is 3 plus 2 over the square root of 3. But again, you want to make sure that you are rationalizing everything as you do it. So this is 3 plus 2 square root of 3 all over 3. If you want to make this 9 over 3, this 3 here, you can make that 9 over 3 and then combine it by saying it's 9 plus 2 square root of 3 all over 3. Otherwise, this is a good answer. This was on your last quiz. So we need to be careful with this first part of information. This tangent of theta is less than 0. That means that tangent is negative. So I either have to be in quadrant 2 or quadrant 4. Because here cosine is also negative, that means I'm going to be in quadrant 2. Okay, so I draw my angle. It's a reference angle in here. Cosine is adjacent over hypotenuse. So this is negative 12 and 13. Okay, a lot of us on our quiz, we made the mistake of saying that this here is 13, but you have to make sure you're labeling appropriately. Then when you do the Pythagorean theorem, you have to plug in your hypotenuse for C. So this is negative 12 squared plus x squared equals 13 squared. I'm not going to go through and solve that. You should be able to get x equals 5, right? X squared equals 25, so you get x equals 5. So this here is 5, and because we are going up, it's going to be positive. So then we can find everything. So sine of theta, so this is nice because there's no radical. Sine of theta is opposite over hypotenuse, so that's 5 over 13. Cosine we have tangent of theta, opposite over adjacent. Opposite is 5 over negative 12. Cosecant of theta, that is hypotenuse over opposite. So 13 over 5, which makes sense because I can just flip around the sign. Secant of theta is hypotenuse over adjacent. So hypotenuse over adjacent. And then cotangent is adjacent, negative 12, over opposite, over 5. And that's it. For the second one, very similarly, cosine of theta is less than 0, which means I have to be, because cosine is negative, I have to be in either quadrant 2 or 3. Then cotangent, the reciprocal of tangent, is positive, so I'm going to be in quadrant 3 down here. So this is my angle, this is theta. Cotangent, that is adjacent over opposite. So adjacent is up here, over the opposite is over here. Look at where your signs are for everything. We're going backwards on the x-axis, so 7 is negative, and we're going down on the y-axis, so 9 is also negative. So here now I can find out what the hypotenuse is. So this is going to be 49 plus 81 equals c squared. So when you do this, you get 130 equals c squared. So c is the square root of 130. Okay, so now you can tell me everything. So this, let's label that first. So this is square root of 130. So sine of theta, opposite over hypotenuse. So negative 9 over the square root of 130 is really negative 9 square root of 130 over 130. Rationalize, this is negative. Cosine of theta, same thing, but it's adjacent now over hypotenuse. So negative 7 over the square root of 130. We clean it up, it becomes negative 7 radical 130 over 130. Tangent, I can take the question up here for tangent because this is 7 over 9 for the cotangent, so I take the reciprocal and I get 9 over 7. And then we have 2 more. Cosecant of theta, hypotenuse over opposite, and then secant, hypotenuse over adjacent. So hypotenuse over adjacent. Okay. And now for this last one down here. So here it's giving you a point. So 6, -4, if you think about where that is on your coordinate grid, you are in the 4th quadrant. You are going over 6 and down 4. So over 6 and down 4. So this is -4. Now we have to figure out what the hypotenuse is. So this is going to be 36 plus 16 equals c squared. C squared equals 52. So c is the square root of 52, which actually can be simplified because 4 goes into 52. So this is going to be 2 square root of 13. So we have 2 square root of 13. So when I find all of these now, because I need to find all 6 here, sine of theta, sine is opposite, this is my angle, opposite over hypotenuse. So first, this really becomes -2 over the square root of 13. Right? You can cancel out the 4 and the 2. And then to rationalize it, it is -2 square root of 13 over 13. The cosine of theta, that is adjacent over the hypotenuse. So this is 3 divided by the square root of 13, which becomes 3 square root of 13 all over 13. Tangent of theta, opposite over adjacent. So this is -2 over 3. The cosecant of theta is hypotenuse over opposite. So this is negative square root of 13 divided by 2. Secant, hypotenuse over adjacent. So hypotenuse over the adjacent becomes the square root of 13 over 3. And then the cotangent is a nice one. Cotangent is adjacent over opposite. Adjacent is 6 divided by the opposite is -4, becomes -3 over 2. Okay, again, because we are in the 4th quadrant, only cosine and secant should be positive and everything else should be negative, which it all does check out. Verify using the following trig identities. So here, you're going to just show that it's true for whatever your value is that I'm asking you to plug in. So here, I'm asking you to do the main Pythagorean identity, and then I'm asking you to plug in 5 pi over 6 to make sure that it all works out. So here, you're going to type in into your calculator the sine of 5 pi over 6. And then whatever you get, you're going to square it, plus the cosine, 5 pi over 6. Whatever you get, you're going to square it, and it should be equal to 1. So you need to use exact values. Okay, so when you type in this sine of 5 pi divided by 6, you should get 1 over 2 squared plus negative square root of 3 over 2 squared. Again, remember your fancy decimals, equals 1. So this is 1 over 4 plus 3 over 4 equals 1. So I'm just going to continue this over here. So 1 over 3 gives me 4 over 4, which equals 1, and this is 1 equals 1. When you are finishing these, you are not done until you have the same thing equals the same thing. So here I have 1 equals 1, that's it. Okay, I really want you to not even put 4 over 4 equals 1 and be done, even though you know that that should be 1. Write it that way. I know that you know it's the same thing is equal to the same thing. That's why it works. So for the second one here, you actually need to do a little bit more work because we have some reciprocal functions, but it's the same exact thing. So here you need to do the cotangent of 3 pi over 4 squared, and that should be equal to the cosecant of 3 pi, this is 3, over 4 squared minus 1. So I'm going to do some work on the side here. We can't plug into our calculator the cotangent or the cosecant. Instead, when I plug in the tangent of 3 pi over 4 into my calculator, I get 1. I get negative 1. So the reciprocal of negative 1 is negative 1. So this is negative 1 over here squared is equal to, the reciprocal of cosecant is sine. So the sine of 3 pi over 4. I type that into my calculator, I get the square root of 2 all over 2. The reciprocal of that is 2 over the square root of 2 squared minus 1. I don't have to worry about rationalizing it here because what happens is this is 1 is equal to 2 squared is 4 over the square root of 2 squared is 2 minus 1. So I'm going to come up here with this. So this is 1 equals 2 minus 1. And again, I know that that is true already, but I want you to write 1 equals 1. Okay, I want you to have the same thing on each side of the equal sign. That way you know for a fact that it's true. Okay, moving down. The last one here. So this one isn't as bad as that last one because I only have one reciprocal function. So with this one, I need to substitute in 4 pi over 3 for theta. So this is tangent of 4 pi over 3. And then I'm going to square that number. And that should be equal to the secant of 4 pi over 3. And I'm going to square that, minus 1. So in my calculator, the tangent of 4 pi divided by 3 gives me 1.732. But again, I need to look at that decimal and make sure I'm using exact value because that's what the question is asking me to do. So 1.732 is really the square root of 3 squared is equal to, so I need to do some side work again because I can't plug in secant. So I need to do the cosine of 4 pi over 3. When I type that into my calculator, I get negative 1 over 2. Reciprocal of that is negative 2 over 1. So, and then we have minus 1. The square root of 3 squared is 3 is equal to negative 2 squared is 4 minus 1. But again, I want to make sure that I have the same thing on both sides of the equal sign. So I write 3 equals 3. And that's it for verifying an identity. Okay, so now we're going to move on to some graphs. So this is more stuff that we've been doing all week. So I really need 3 pieces of information. I'm graphing all of these on the interval from 0 to 2 pi. So I need the amplitude. Let me do this in a different color. I need the amplitude, the midline, and the period. Okay, amplitude here is 1, right? The number in front that you are multiplying whatever function it is. So here it's 2 plus 1 times the sine. The midline is y equals 2, and then the period is 2 pi divided by your b value, so 2 pi over 3. So when I go to graph this, you guys are going to have much neater graphs than I do because I don't have the graph paper in front of me, but you have graph paper on the back of your answer key that you should be using for these. Your curves need to be nice and smooth. Okay, you cannot have any pointy peaks because that is not a trig function. That is not what we are doing here. Okay, everything needs to be nice and neat. If you are not nice and clean and you have nice curves, then you are going to lose points now and in June. So I'm going to have this as my x-axis. My y-axis, I need to go up to 2 as my midline, and then I go up 1 and down 1. So make sure you label that. And now for my x-axis, I have 4 slashes and then the period. 4 slashes and then the period. 4 slashes and then the period. I stop at 2 pi because that's what my interval is. Okay, this was really 6 pi over 3, so that becomes 2 pi, so I stop there. So now when I actually go to graph this, sines, the y-intercept is the midline. And then my next, because this is positive here, I head up. And then midline, down, midline. And that is one full cycle. But I keep going until I get to the very end. And it should look like that. Okay, again, not as shaky as mine, but that is what it should look like, a basic curve. Okay. Next graph, I need the same three pieces of information. I need the amplitude. The amplitude here is 3. The absolute value, right? The amplitude's not negative 3. I need the midline is y equals 5. And then the period is 2 pi over 2, which is just pi. So now when I go to graph this, I am all the way up here. So when I go to graph this, my y-axis, I have 1, 2, 3, 4, 5 as my midline. I'm actually going to keep going, so this might be a little tricky to see. And then I'm going up and down 3 because my amplitude is 3. So I have 1, 2, 3 up to 8, and then down 3, 4, 3, 2 to 2. So now I have my x-axis. Every 4 dashes represents one cycle. So one cycle gives me to pi. And I have 1, 2, 3, 4. Pi plus pi is 2 pi. I stop there. I stop at 2 pi. Cosine negative, I start underneath my midline and then I come up. So it should look like this. Again, nice, smooth curves. Not like mine. For number 15. Number 15, here I have another cosine graph. I need same three pieces of information every single time. The amplitude here is 2. The midline is y equals 4. And then the period here is 2 pi over 1, which is just 2 pi. So when I go to graph it, I'm going, my midline is all the way up at y equals 4. And then I head up another 2 for my amplitude. And then down 2 for my lower side. And then for my y-axis, 2, 3, 4, 2 pi, I stop there. So when I actually go to graph this now, this is my midline. I am positive cosine, so I start up here and then come down here and then down. And this is one complete cycle. And then for number 16, so 16 is a little bit different because we have theta divided by 2. That's the same thing as 1/2 times theta. So don't let that bother you at all. So when I find my three piece of information, my amplitude here is 4. My midline is y equals -1. And then the period is 2 pi divided by 1/2. Which is really 2 pi times 2 over 1. 2 over 1. So my period is really 4 pi. So we're only graphing from 0 to 2 pi. I am not going all the way to 4 pi here, so I'm not going to see a full cycle on this interval of this function. So when I go to graph it, I need to draw my midline is down at -1, then I'm going down another 4. So 1, 2, 3, 4 is -5, up 1, 2, 3, 4 is 4. I'm sorry, up another 4 gives me to 3. So this should be a 3 here. Then we have 1, 2, 3, 4 gives me 4 pi, but I'm not graphing all of that. I'm only graphing up to 2 pi, so I really only need these two lines here. So that when I actually go to start this, I have a negative sign. So I'm going to start still on the midline down here, but then I'm going to head down to the bottom half of the amplitude and then come back up to the midline. So this only looks like this. And that's it. Phase shifts of the sinusoidal functions. So sinusoidal, that just means it's going to be cosine or sine. So for number 17, to find the phase shift here, I have to factor out whatever number I have in front of my variable. My variable in this case is theta, so I have to take out a 3. So when I take 3 from 3 theta, that's easy. I'm only left with theta. But when I take 3 from pi over 3, I need to do pi over 3 divided by 3. That's really pi over 3 times 1 over 3 gives me pi over 9. If you remember, I told you in class you can just multiply. If you don't have enough to divide from the top, multiply to the bottom. So this is plus pi over 9. So this is a phase shift. I'm going to the left, pi over 9. Okay? Second one's a little bit easier because I do have enough in the numerator to take out. So when I go to actually factor out this 2, I'm left with theta minus 2 pi over 3. So this is a phase shift right, because I'm negative, right, 2 pi over 3. And that's it. All right, for the remaining ones, it's going to ask you to write the equation of the functions. So we've been doing this a whole bunch in class. So number 19, write the equation of the trig function with that range, that period, and it passes through that point. So from my range, I can figure out the amplitude and the midline. So to find I do the midline first because I just take the average of the two. So this is negative 4 plus 6 over 2 gives me 2 over 2. 2 over 2, which is 1. So my midline is y equals 1. Then the amplitude, so I'm going up to 6 and down to negative 4 from y equals 1. It should be the same distance. So here my amplitude is going to be 5. Another piece of information that's actually pretty nice for us is the period. Period is 2 pi divided by b. In this case, it's 2 pi divided by 5. So right away, we can see that b has to be equal to 5. So that's another piece of information I'm going to need. So because here it passes through the point 0, 1, it passes through the midline, it's going to be a sine function. You have two options here. It could be positive sign or negative sign. We don't have enough information to tell that, so either one of these would be fine. Okay, you can end up having either answer and it still works out. So your final answer here, I'm going to do the positive just because it's a little bit easier for me. So this is y equals 5 times the sine of 5 theta, close your parenthesis, plus your midline is plus 1. And that's it. For number 20, write the equation of the trig function with that range, period, and it passes through a point. So same information. So right away I'm going to do the average of the range in order to find the midline. So this is negative 6 over 2, so my midline is negative 3. So midline is y equals negative 3. The amplitude then, if I'm at negative 3 and I'm going up and down to negative 5 and negative 1, my amplitude is going to be 2. And now I need to figure out what my b value is. So because I know that the period is pi over 6 and period is normally 2 pi over b, I cross multiply and I get 12 pi equals b pi. So 12 has to be my b value. So b is 12. And then the last thing, I need to figure out if it's sine or cosine or if it's positive or negative. So here, it passes through the point 0, negative 5. So it doesn't pass through my midline, so it's going to be cosine. And then it passes the lower boundary, so it passes the minimum range, so it's going to be negative cosine. So my final answer here, y equals negative 2 cosine of 12 theta, close your parenthesis, minus 3. And that's it for that one. Then the last one that's here is a graph. So I'm going to identify my midline right away. That's y equals negative 3. Remember, if you look, these are going by 2, so you have to be careful. So my midline is y equals negative 3. My amplitude is 1. And then the period is how long it takes me to complete a full cycle. So my period is 2 pi. Or I can just see how many, I can see my b value right away in here. I can see how many cycles I complete from 0 to 2 pi, and in this case it's 1. Or I could also find that from doing the period. This is negative cosine because I start down here. So my answer is y equals negative 1 cosine of 1 theta, or cosine of theta, minus 3. And that's my answer. You don't even need the 1 in front of the cosine. You can just write negative cosine theta. And the last one. So my last one is another function with a graph. So I'm going to identify my midline. So my midline is y equals positive 3. My amplitude here is also 1. And then my b value, how many cycles from 0 until 2 pi. So I go around once, twice, so b value is 2. I could also say it takes me that the period is pi, and then I can figure it out that way also, whatever you want to do, not a big deal. Because this starts on my midline, it is a sine function, and because it heads up after, it's a positive sign. So my final answer here is going to be y equals 1 sine 2 theta plus 3. And that is it. Remember, extra help is Thursday after school. If you have any questions, feel free to come. Feel free to email me. Okay, you all know my email by now. So if you have any issues at all or anything with the video, then just let me know. Have a good night.